Hey, it's Mr. Kingsbury again, here with a little more Algebra 2 action for you. Remember, our unit we're currently studying is Systems of Equations. Today we're going to look at elimination. Our essential question is, how do I solve a system of three equations with three unknowns using elimination? And I've just got a couple of examples for you. So I'll go through them and I'll try and do it quickly, and then life will be good. So here's our first example. Let's say we have the system x plus y equals -4, 3x minus y equals -8, and 2x plus 4y minus 2z equals -18. The first thing I would do is look at my equations and see how many variables are in each and what they are. And what I notice is the first and second equations both have x and y, but no z. The last equation has a z. That means I'm going to save this last equation here, equation 3, for the very end when I need to figure out what exactly z is. So I'm going to hold off on that for now. Instead, I'm going to focus here. Now, the idea behind elimination is that when you add two variables, their coefficients essentially cancel out and give you a coefficient of 0, which cancels out the variable. Thus, it is eliminated. In order to do that, then the coefficients need to be the same number but different signs. So when you add together, they cancel out. I'm looking at our first two equations here, and what jumps out at me is these are both y. One is positive, one is negative. I love that. I love everything about that. So I'm going to take x plus y minus 4, and to that I will add 3x minus y equals -8. I'm going to add down. 1x plus 3x's is 4x's. Y plus -y is 0 y's, which means the y eliminates. And I don't think I did a very fabulous job writing this. This should be equals -y. Sorry about that. -4 plus -8 is -12. So I have this equation, 4x equals -12. Or if you will, 4 times x equals -12. Then I will divide both sides by 4, and I get that x equals -3. So one variable down, 2 to go. Now I can plug this into either of my other equations, doesn't matter which. I'm just going to use this top one, x plus y equals -4. I'm going to replace x with -3. So I have -3 plus y equals -4. And then I will add 3 to both sides. -3 plus 3 is 0. 0 plus y is y. That was the whole point there. It said it cancels out. -4 plus 3 is -1. So I now know that y is equal to -1. The only thing I don't know is what z is. So I can take my x and my y values and plug it into this last equation for x and y. So we got 2 times -3 plus 4 times -1 minus 2z should equal -18. 2 times -3 is -6. 4 times -1 is -4. And we're still subtracting 2z, and that equals -18. -6 minus 4 is -10. So I have -10 minus 2z equals -18. And now I will add 10 to both sides. -10 plus 10 is 0. 0 minus 2z is -2z. -18 plus 10 is -8. So I have -2 times z gives me -8. And I can divide both sides by -2. And z equals +4. So x, y, z equals -3, -1, 4. There you go. Let me give you one more example, and then I will leave you be. So let's see, next example here. It's going to take a little bit more work, but not tons. All right, not huge amounts. So let's say 2a minus 4b equals 16, and 3a plus 2b equals 8. And then lastly, 5a minus 2b plus 7c equals 24. Cool. So once again, I'm going to look at my equations. I'm going to see what I have, and then I'm going to see if I have a variable whose coefficients in more than one equation cancel each other out, basically. So first equation, I've got two variables, a and b. Second equation, two variables, a and b. Last equation, three variables, a, b, and c. Since this is the only one with c, I'm going to use that one to solve for c. And in order to get c, I'm going to need to know what a and b are. So it looks like I'm going to focus on the first two equations and see what I can do with them. Now, if I add 2a and 3a, I don't get 0 a's. If I add negative 4b and positive 2b, I get negative 2b, which again is not a 0. However, 2 is a factor of 4. And, in fact, if I multiply the whole equation by 2, then something cool happens. So 2 times 3a is 6a, 2 times 2b is 4b, and 2 times 8 is 16. On top, I'm going to leave this the same. I'm just going to copy it. 2a minus 4b equals 16. And if you look at my b's, I now have a negative 4b and a positive 4b. Negative 4 and positive 4 add to give me 0. So when I add down, those cancel. 2a plus 6a is 8a, and that equals 32. I'll then divide both sides by negative 8. A equals negative 4. So I know what A is. I don't know what B is yet, though. So let's take this A value and plug it into either of my two first equations. Doesn't matter which. I happen to like 3A plus 2B equals 8 because the coefficients are all positive. So I'm going to plug it in there. So we got 3A plus 2B equals 8, and I'm going to replace A with negative 4. So 3 times negative 4 plus 2b equals 8. And 3 times negative 4 is negative 12. So negative 12 plus 2b equals 8. I will add 12 to both sides. Negative 12 plus 12 is 0. 0 plus 2b is 2b. 8 plus 12 is 20. So I get 2 times b equals 20. I will divide both sides by 2, and b equals 10. So I now know what A is. I know what B is. Last thing I need to do is plug into this equation. I will plug A and B in there and find C. So I'm going to have 5 times negative 4 minus 2 times 10 plus 7C. That's going to equal 24. 2 times negative 4 is negative 20. Negative 2 times 10 is negative 20. Plus 7C equals 24. Negative 20 minus 20 is negative 40. So I have negative 40 plus 7C equals 24. I can add 40 to both sides. I get 7C equals 64. And they're kind of running together here. Sorry about that. Not intentional, I swear. I think I did that right. So then I'll divide both sides by 7. C will equal 64 sevenths because I'm not dividing that out. It's going to be gross. So my answer is X, Y, Z equals negative 4, 10, and 64 sevenths. Boom. Thanks for stopping by. See you in class.